Hi, yes, we've got another exclusive for you. Siglent very kindly loaned me their brand spanking new, to be released in a couple of days, SDS1104X-E oscilloscope. And we've seen the X-E oscilloscope before. I think back in April, early this year, I did a teardown of the 1102 or the 1202X-E, the 200 megahertz version. Well, look, this is their new 4-channel version. Check it out. It's basically an identical platform to the existing 1102 and 1202 2-channel X-E series oscilloscope, which they released earlier in the year. And that was exciting enough, but of course it was only 2 channels. But it just couldn't compete with the venerable Rigol DS1054Z because it, as well, up until now perhaps, was the pretty much the only game in town in low-cost 4-channel scopes. It basically owned it. But everyone's playing catch-up, and we're starting to see a spate of these competitive entry-level 4-channel scopes, and this is fantastic. Now, the retail price on this puppy is going to be $499 US dollars for the 100 megahertz version that we see here, the 1104X-E, and this is actually way below the $620 for the Rigol DS1154Z, which if you don't get the 1054 and you don't hack it, then if you're actually comparing apples and apples to the 100 megahertz bandwidth 4 channels, then this one actually undercuts the 4-channel Rigol. But of course, the hack's available for the Rigol, and everyone just buys the 50 megahertz version and hacks it up to 100 megahertz and gets all the goodness built in. But this Siglent is designed to be completely competitive with that, although it is a higher price point. So the Rigol is currently available for like $350 US dollars on sale or something like that, which is absolutely crazy for a 4-channel scope. So this one is more expensive, but it is a 100 megahertz base model unit. So yes, it is more expensive, but when you compare apples and apples, it's actually cheaper. So basically all the features are the same as the 2-channel version. It's got the 14 meg sample memory as standard, 100K waveform updates per second, which is like 3 times the Rigol, 256 level intensity grayscale display, 1 meg FFT, which is really powerful, and it includes the free serial decoders for the cost. No need to hack anything. They throw in all the serial decoders for free. Fantastic. It also does baud plotting, which is a little competitive head nod to the Keysight 1000X series, which of course includes that cute little baud plotting feature. And whilst this doesn't include an arbitrary function generator, you can get one as an optional extra, and we'll tear down this as well. It is a separate USB dongle type device which you plug in and gives you a 25 meg bandwidth, 125 meg sample per second arbitrary function generator. So we'll do a quick teardown of that too. And also it includes MSO capability as well, but they said that's not ready yet. But once again, that'll be an external USB thing to turn it into a mixed signal scope as well. So this is pretty exciting. 4-channel scopes are really, there's more than just Siglent and Rigol. Now there's the GW Instec one and other players coming on the market on these low-cost 4-channel scopes. So a very exciting time to get to be buying an entry-level scope. So we're going to do a quick teardown. I expect it to be almost identical to the 2-channel version. And just on the back, for those playing along at home, we've got our pass-fail trigger output, LAN as standard, and the requisite USB. And another optional extra, which you can buy, they have included it, is a little Wi-Fi dongle which plugs into the USB on the back there. So that's kind of neat. And we have the requisite metalwork. No signs of any trademark Siglent rust by the looks of it. But before we whip this thing open, if you compare it with the teardown video and photos of the previous unit, actually had the board on the back here, and the Ethernet was like up here, and so it had the vertical processor board. This one's different, of course. It's got the I/O over here like this, so the main board is going to be on the bottom with the power supply in there. So they've got to architecture it different because it is physically larger with the 4 channels and things like that. So let's open. Hey, it's not bad. And we are in like Flynn. Errol, that is. And one of the first differences you notice, apart from the main board being on the back instead of vertical like we got on the 2-channel, is that the power supply is up in here and it is shielded, unlike the 2-channel model, which actually the vertical board was here and the power supply was just open, stuck in here like this. So yeah, it's got more metalwork. That's good. If we take a look at the main board here, I've taken the shield off the front ends here, and the architecture looks to be basically identical to what we had before. We've got our FPGA and processor under here. We've still only got the one handling everything. We've got our sample memory tied onto that there. I don't know why they've only got 3. They've got a 4th one unpopulated there, but basically you can see how they get the cost down on these things. It's basically a 4-channel 200 megahertz front end, because yes, guaranteed the 100 megahertz model will have the 200 megahertz front end in it. Just everyone does that these days. So it's very likely that you can hack this up to 200 megahertz somehow. You can see there's basically not much else. We've got our power supply stuff around here, some looks like some level translators and stuff like that. Nothing much, doing some stuff around here for your external signal generation and stuff like that, but it's basically the big zinc processor under there, and Bob's your uncle. And if we have a look at the power supply, it looks quite nice. We've got our nice earth strap going down to the crimp terminal with the shake-proof washer down onto the directly down onto the stud down there. Very nice. The board looks very nicely designed. We've got our high voltage isolation slots. It's got all the requisite stuff. We've got our input filter in our common mode choke and everything, and the isolation slots down near the bridge rectifier. We've got a Lelon. Is that a Lelon? That looks like a Lelon to me. Yeah, whatever. Okay. But, par for the course in ones like this. Somebody really enjoys their Scholastic gun there, and they like just following that around just to stop the capacitors flapping around in the breeze. Speaking of flapping around in the breeze, there's that one down there. There's a bit of Scholastic under that, and I thought, hey, that's not good because that's close to the metal cage here, but I checked and that is actually electrically connected through to earth anyway. So yeah. Anyway, just have it a flap around in the breeze next to the metal there. Could be a real trap for the young players. It's got nice strapping over the transformer there. Everything looks fine and dandy. What are those capacitors in there? I don't know. I can't read that on the screen. Tiny little kangaroo. Hey, they're Rubicons. Not bad at all. So that really is very nice. Rubicon caps on the output, very nicely designed and manufactured by the look of it. I like the little lead sync down there on the little surface mount TO package there, but yeah, thumbs up to that. Alright, so let's have a squiz under the Teardown microscope here. Nothing interesting happening around, all that sort of stuff. There you go. ALVC translators or whatever. What have you. Let's have a look down here. Nothing interesting happening. Got a couple of linear regs there. And of course, one of the big things is that we're going to have 2 analog to digital converters, which are, well, I'll show you in a second, there and there, because we've got one that shares the dual channel. And you have to have the 2 ADCs in there to keep your sample rate up. In this case, it's 1 gig sample per second, but if you enable all 4 channels, then it drops down to 500 meg samples per second, which is good enough for 100 megahertz bandwidth. Not great at all. Barely adequate with sine X on X interpolation for your 200 megahertz bandwidth model, so not great. So yeah, the 200 megahertz bandwidth of this sounds great, but when you don't have the sample rate to kind of match it, it's a bit disappointing. And of course, we've got the HAD 1511 there. If I block off the light a little bit, you can see, yep, a standard one used in practically everything these days. Now, if we have a look at the analog front end, it is practically identical layout to the previous one. So the only major difference I can see at first glance is it's got the extra capacitor populated on the footprint there, so that's interesting. But apart from that, it looks near identical to what we had before. So yep, which is exactly what you'd expect. Of course, they're using exactly the same front end. So there you go. Anyway, there'll be high-res photos over on EEVblog.com for those playing along at home. And then under here we have our FPGA. I can't take it off. It's got the thermal adhesive on there, but it's going to be, well, either exactly the same or a slightly increased part. But it's Siglent have said it's the Xilinx Zinc processor, which is a dual ARM Cortex A9 or whatever it is, plus the Artex FPGA architecture. So it's a combined processor and FPGA, and it is incredibly powerful beast. I don't know why they've only populated the 3 parts there. They're all identical memory, are they? Anyway, you can decode the part numbers for those playing along at home. It has 14 meg samples standard, so yeah, why they've got 3, maybe they've got 2 to handle all 4 channels, maybe there's some more on the bottom side, I don't know. Not particularly fast. It's basically exactly the same architecture as we had on the FPGA and the 2-channel version. What's that? Look at that. NAND. J1 JTAG. Is that next to what? That one? And then that seems 3 pins. That seems a bit weird. Anyway, that's just for programming the NAND flash memory, presumably, but it's got a header as well. That one is for the Zinc. See? ZYNQ. So that is the JPEG, I presume, the JTAG header for the Zinc. Interestingly, got a reset pin up there. Maybe we can use that to reboot into some debug mode, because on the previous teardown we did actually hook up to the serial port and get the dump out of the thing, and that's where you're going to be getting the dump from, the TX and RX. No doubt it has the U-boot thing in it, and we'll be able to get the boot code out of that. So the hackability in this thing should be pretty decent. And curiously, right over next to the power connector, we've got another 5-pin header in there as well. What's going on? Is it for that little puppy? What is that thing? Not quite sure why they felt the need to put some tape over that. Is there a shorting wrist to something on the top of the case? I didn't think so. Anyway, that's our front panel USB, so don't know what's doing there. Alright, let's have a look at the boot of this thing. I've got it hooked up via a serial port, USB serial port, 115K board here, 8N1, all the usual stuff. I've just actually powered it off, and there's the data when you actually power it off. So here we go, power it up. There you go, U-boot, we get all the requisite stuff. And I'll copy this into a text format and link it in down below for those who want it. And we should eventually get to a prompt. Come on, you can do it. And I think we're in like Flynn. And we'll have a quick look inside the Arbitrary waveform generator, which is a option, of course. We've got ourselves a Cypress USB interface down here and a Cyclone 4 FPGA. That's exactly what you'd expect. 74H, got to have a 74HC405 one in there. Couple of NEC relay jobbies. And what was that? An LMH6702, I believe. From memory, that's an output driver. That's exactly what you'd expect, given that its proximity to the output here. What else have we got? And an OPA 695 wideband current feedback op amp. What else have we got? No output. Oh, there's our 49. There's our 50 ohm output resistance. Not much else happening on here, is there? There we go. That's got. Is that our DAC? What's that? We've got a negative. We've got our negative rail generator down in there. Not much else. LM393 classic dual op amp. Let's have a look on the bottom here. Aha, now we're talking. There's our DAC. It's a Burr Brown job. Love Burr Brown. DAC 904. There's still Burr Brown. DAC 904. Gotta have a TL072, don't you? Another 50 ohm output resistor. Another drive. I'm not sure what that number is offhand. Have to check that up. And a 3-peak. Who's a 3? Who or what is 3-peak? That's interesting. TP1272. Sure enough, that's a single supply rail to rail op amp. Go figure. Anyway, another 4051, but that's about all she wrote on there. Nothing too interesting. So anyway, that is the optional. Whoops. I hate it when your light pipe falls off. That goes on there. There you go. It gets the LEDs out to the front panel. That's quite neat. And of course, they save cost by not building this into the scope. If you want the arbitrary waveform generator, you pay for it. Fair enough. As long as the software integration's good, I don't mind that concept at all. So there you have it. That's a look inside the new Siglent SDS1104X-E 4-channel scope. Yeah, it's... Hello? There we go. That's our piezoelectric effect. It's actually not too shabby. Let me... Oh, no. There we go. Hang on. Single shot. Oh, isn't it cute? Look at that. We can put it in... Oh, normal mode. There we go. Oh, hey. Why do we have dual waveforms like that? What's going on? Is that a bug? We're in normal mode. I'd expect it to give me one update, not two. Is that what? What? Why is it doing that? Anyway, yeah, that's our typical piezoelectric shock response, which we get on almost every scope, but geez, that's... Oh, there we go. No, you really need the high frequency metal on metal like that, but I don't understand what's going on there. It shouldn't do that in normal mode. You should just get... Normal mode is basically a single shot capture. I don't get that at all. It's gone through and it's not disarming the sweep, and you only ever get two of them. I don't get it. You don't get that with the Rigol. Look at that. No worries whatsoever. Normal mode gives you exactly what you'd expect. Siglent. And another competitor, the 4-channel GW Instax GDS1104B. It's a very significantly different front-end response, so it's mechanically coupled very... Whoa, wow. Very, very differently, but anyway. Now this is interesting. If we try the Keysight one here, right, we got a similar thing happening in normal mode, of course. But look, it see, it popped up with the multiple waveforms there, but it figured that you're in normal mode and you wanted that single shot capture, right? Because it's the high update rate, it's going to show the multiple things. So maybe the Siglent one, because it's 100,000 waveform updates per second, the Siglent, which is awesome, but it leaves the artifacts of the see? Whereas the Keysight gets rid of them, as I would expect it to. If I'm in normal mode and I get a single shot thing which triggers my scope, I damn well want it to capture. So the last one, I mean, you know, because there's multiple trigger points there with this thing. Maybe if I do it like that, it's going to be a bit more controlled. Yep, right. But because I'm doing the high frequency one like that, there's a bit, you know, I'm getting multiple vibrations coming through, triggering that multiple times. But in the end, you just want one screen like that. So I don't know what the heck's going on with the Siglent. Is it a PEBCAC or just the way it operates? So they think that's better? I don't get it. Oh, check it out. No, the Siglent, it did go away before. I think I captured it there, but now it's not. So, but I did actually see one go away, so I'm not sure what the deal is. It's anyway. That is the new Siglent SDS1104X-E. Thank you, Siglent, for loaning this one before it's released. There you go. Look, it just magically... Was that me talking? Is that I talk so loudly that it's coupling through to the input? I don't know what's going on there. That... It's a bit quirky. More investigation required. Anyway, yes, I do plan on doing videos reviewing and maybe like a shootout comparison or something like that. But it's interesting, $499 US with all the serial decoders built in. By the way, there they are, I2C, SPI, UART, CAN, and LIN buses all built in. The 14 meg sample memory, the Bode plotting, which I haven't looked at yet. But yeah, you can actually do a baud plot. There you go. 1 meg FFT, which is awesome, which you can do these days inside that Zinc FPGA, and which you see on other scopes like the GW Instec one does. If you just want the 1 meg points, that's probably FFT, if that's important. The Siglent, so the GW Instec one's a bit of a killer in that regards. Anyway, this one's got 1 meg FFT as well, and it has Wi-Fi dongles, and maybe it's supposed to have MSO capability, but that's not out yet. And the separate Arbitrary waveform generator, whatchamacallit, is a bit pricey, I believe, for the option. But anyway, this is not a review. I just wanted to show you this because it's very exciting. You can get a 4-channel scope for $499 with all the serial decoders built in, a crap load of sample memory. You know, the sample rate's good enough. I wouldn't be paying the extra for the 200 megahertz one of this. It's just the sample rate's not good enough, especially if you're utilizing all the 4 channels. It's just, you know, it's not great at all. But hey, for the price, if you can hack this thing, which I believe it's going to be hackable, so there's probably going to be a lot at this price point. There's probably going to be a lot of people working on this one. It's likely just like a software hack or something like that. So anyway, we'll see. I've already tried a few things. I've tried to redo the model number and stuff like that. So I've tried to go in and where is it? Update. Yeah, I've tried. No. Where is it? System status. Anyway, I've tried to go in there and change like the model number, the SDS, and it's not sticking and stuff like that. That was a real old Rigol hack back in the day, and that one's not working. But there's probably a way to hopefully hack this. There's no point getting the serial decoders because you get all that for free. So, yeah, there you go. It's pretty jazzy. We are the winners. Now it's... No, see, I don't get it. Anyway, the market's the winner on this one. That's us. 4-channel scopes for like... Well, you can get the Rigol for $350. This one's $499 for 100 meg bandwidth with all the decoder. Crazy. When I was a boy... Anyway, high-res teardown photos down below, discussed down below, that screen dump for the BIOS boot thing, all linked in down below, and videos at the end. If you liked it, please give it a big thumbs up. Engagement always helps. And, you know, there's a subscribe button and watch the videos or whatever. You know the deal. Catch you next time.